Hi, this is Brian Albright. Welcome to the DE 24/7 podcast. I'm here today with Rod Mock, founder and CEO of TotalCAE. Welcome to the program, Rod.
Yeah, thanks for having me today, Brian.
Great. Well, today I wanted to talk to you about some of the factors that people need to consider when they're deciding whether to build or buy a high-performance computing platform. And that can be either on-premise or in the cloud. So first, can you talk a little bit about why customers even consider, building their own HPC cluster environment and what advantages they see to that approach? Because that's something we see a lot when we're covering this technology that people are looking at trying to do this all themselves versus outsourcing. So why are they looking at that in the first place?
Well, in many organizations, engineers have historically been pretty self-sufficient when it comes to their CE tools. So often, they're managing the applications on their Windows workstation. They're kind of like their own admin on that, and that does work. I mean, they need to get their jobs done ultimately, and so they're have resigned to, hey, whatever it takes, I just need to get my work done. Give me full control, and I will do it. But when you step up from kind of like a workstation to an HPC cluster or cloud, they often don't realize the jump in complexity that goes along with that. And sometimes the vendors that are selling you hardware cycles, they kind of convince you that, hey, it'll kind of run itself. We'll just plug it in and, you'll be fine. It'll be just like that workstation. But that isn't really the case. I mean, these are, it's kind of difficult to keep these things working, keep the applications working, make sure it stays reliable and useful. Even though engineers are super smart, we have our clients, build rockets and autonomous vehicles and so on, but managing and upkeeping a cluster, it's just a different set of domain knowledge. It just needs a lot more knowledge than they realize when they get started.
In terms of that DIY approach, what do you see as some of those key challenges for HPC when it comes to on-premise solutions? Are there specific challenges relative to running engineering applications or CAE applications on these platforms?
Yeah, I think that the biggest challenge is often the model that has been maybe popularized over the years is that you would buy a piece of hardware, just like buying a workstation. And then you would be left to kind of integrate it. And so invariably, you could spend, months trying to get everything integrated. And then that's just time spent away from doing your regular day job. In addition, sometimes they'll have the apps work on day one, but then when you need to update to a new version, they find it's not a double click install. It's not like just double clicking and suddenly everything that worked before works now, because there's a lot of intricate moving parts with the cluster that don't exist on a single machine workstation or even on a single machine cloud box. You have middleware like MPI. There's usually some specialized networking called InfiniBand and schedulers. And all of this stuff has to work together to actually get your job done. And if any small piece you miss a step or don't even realize that there's a step to be done, then you might have a problem. One of my favorite stories is that a long time ago, we had a customer who had bought a system like this. They had a cluster bought from someone else, and they had updated they've been doing the apps, and the application performance was just really bad. And they would call the vendor that they bought it from. They're like, oh, we did an InfiniBand check, health check, cluster is working fine, no problem. But the application was really behaving poorly, the CFD app. So we hopped on. We realized that, they haven't been using the low latency network that lets you get speed up when you scale out. It was still using Ethernet. They had no idea. Ended up being like they've been running for years at a 40% slower rate than they should have. So that's the case where, unless you're taking ownership from, all the way up through the app, you may not even realize, they had a sense that it should be faster, but didn't know how to solve it. And that's some of the challenges of a DIY approach. You don't know the unknown unknowns. You don't know what you don't know. And so it can be challenging, and you end up having to try to, find someone to take responsibility. But typically, there's too many cooks. Which cook do you blame? And that is kind of like what TotalCAE solves. I mean, we're only just one number to call. We have an A team of experts here that know all the different pieces and work together to get the solution done. So you're not having to kind of figure it out on your own, basically. So then that's kind of the challenge of doing it yourself is if you don't have complete domain knowledge of that area, you could run into a roadblock that just throws your investment totally off course.
A lot of engineering organizations and the software vendors too are leveraging cloud-based compute resources now. For this type of DIY scenario, how is that different if you're using cloud-based HPC versus trying to implement, on-premise HPC?
Yeah, now with the cloud is an incredible technology. It lets engineers access a lot of compute resources that may have been out of their reach before. So there's two kinds of clouds. There's a do-it-yourself where you're like, hey, I have a bunch of hardware and I need to assemble it. And then there's using a SaaS type solution like TotalCAE offers, where it's like a web portal and you just click a button and it runs. So if you try to build basically a turnkey SaaS type solution on your own, that is like even one level higher of all the expertise needed on premise. It's actually even more complicated, because you first have to have what I would say is another building block of domain knowledge. So you have to first understand cloud, vernacular, like you need to know what an AMI, S3, VPC, IAM, EFA, EBS, all of these like soup du jour. You need to first even just know what those are and understand them in depth to start. And it might take, to go through to get that kind of training might take you a couple months. Then you need to have very good programming skills, because the great thing about the cloud is it's all programmable. You can spin up machines and turn things on and off, all through APIs and software interfaces. But if you don't have strong programming skills, you're not going to be able to assemble a solution nor maintain it, debug it, optimize it. And so, if you log into a cloud console where they have a button and you can stand up something that looks like a cluster, that doesn't, that still only gets you halfway. Then you still need to get all your apps integrated, deal with the cloud specifics. One of the cloud vendors does have like a cookbook guide, how to get started. I think it's 62 pages long or something like that. And so you just have to, if you just crack open the book and start from step one, it's going to take a while. So again, most of our customers don't want to be in the business of like building their tools if they don't have to. They really want to be in they just want to do their CE work and not have the tool bog them down.
Now, your company, obviously offers a turnkey solution in these HPC appliances.
Mm-hmm.
What are some of the key benefits for your customers in terms of the deployment, the configuration, and the support that type of approach can provide versus, that DIY approach that we've been discussing?
Yeah, I think one of the biggest advantages is you can get started immediately, and then that the experience you have on day one is the same experience you're going to have on day 300, 365, 762. We're there every single day with the customer, making sure their simulations get done. So on the case of on-premise, it's an appliance. We drop it off, we plug it in, and you immediately can start uploading your models and running simulations. So within an hour, you're running. And you really don't have to have a lot of knowledge. If you can click 3 mouse buttons, you can basically run hundreds of different engineering apps out of the box. And if you have any challenges, you just call us, and within 1 hour of email or just pick up the phone, within 3 rings, someone's going to be there to help you to make sure you can get your deadlines. And we have a software as a service platform, same kind of web portal, exactly the same on the cloud. The only real difference between our cloud and the on-premise system is that we give you a lot of billing controls. The cloud is kind of pay-as-you-go. Make sure you understand how much each job costs. We help make sure you stay in your cloud simulation budget. But much as from a workflow perspective, exactly the same. And we host that like in the customer's cloud subscription or our own, on Azure, AWS, Google, Oracle, many of these cloud infrastructure vendors. They're just like the hardware vendors that we support on-prem, Dell, HP, Lenovo, and others. So, it just comes down to peace of mind, knowing that the solution you pick is going to be a tool you can rely on to get your deadline done and not be a hassle or feel like it's like slowing you down or not be, not take your simulation to the next level where you're like, hey, I'm just going to fall back to the workstation. I can't trust that tool to meet my deadline. And that's a lot of the reasons that customers choose something turnkey. They want to focus on their business and not on the business of being a tool builder.
Can you talk a little too about, and I think this is something maybe people don't necessarily consider right away, some of the benefits of this approach relative to things like job scheduling and some of the software licensing management that even goes into this that isn't necessarily directly related to doing the job of engineering, but can create some issues on the back end.
Yeah, definitely like CA license. So CA licensing does offer a special wrinkle. That is often the most expensive part of any solution is the licensing for your engineering application. And so we take care of a lot of the details. For example, on cloud, if you want to run a job, you don't want the computers, which are usually nearly infinite, to turn on if you don't have a license to run it. So that's just seems very common sense, but very actually challenging in practice to make sure that you can check the licensing. We automatically calculate the number of licenses you need and take care of only turning on compute power when you have a license available to run it. And so that does, that is like a simple case of, okay, you need to build that. That doesn't come, there's no out of the box solution that comes with any cloud vendor that says, we're going to take care of that for you, for example. And the other thing that can be sometimes surprising to people outside of our space is that just because you ask an application to run, it often doesn't just run to completion. Engineers are constantly monitoring their jobs. It might not converge. It might be stalling. There's all kinds of things that go wrong with that. And so when you're running on cloud, especially, that's costing you money. You may not be getting a useful result because it's like, it's not converging properly, but you're still getting paid. You're still getting billed for that. And so we built tools that will monitor the engineering application output and say, oh, well, we realize this doesn't look right. Instead of you like constantly checking day in, day out, weekends, after hours, we'll email you and say, hey, you might want to check on the simulation that's costing you $75 an hour. It doesn't seem like it's doing the right thing. So it's those little things that, definitely make a usability big difference that you could spend a ton of time on solving a solved problem that we've already, solved for, customers, for doing this for so long that you may not even think of until you get into it.
All right. Well, thank you very much for talking to us about this today, Rod.
Yeah, thanks for having me. I appreciate it. And it was very, very good seeing you again.